Hello everyone. In this video, the Humble Math Tutor offers you a way to solve all distance, rate, and time problems, a unifying approach, if you will. We take information in a word problem and place it in a 6-cell chart. We next observe that distance is rate times time, and we set up an equation to solve. Let's try this with this problem. A train travels 395 kilometers over 9 hours. For some of the voyage, the train travels 40 kilometers per hour. For the rest of the voyage, the train travels 50 kilometers per hour. For how long did the train travel at each speed? So it's as if the train went along for a while at 40 kilometers per hour, and then at some point it switched speeds and went 50 kilometers per hour until we got to the end of the trip, which is 395 kilometers later. What we do is we organize all this information in a 6-cell chart. So we make up 2 rows and 3 columns like this. Distance column, rate column, time column. Those are the 2 rows, 3 columns, and we label the rows 2. So this will be the first leg of the journey, right? So this will be leg number 1, the 40 kilometer per hour leg. And this is the second leg of the journey, leg 2, the 50 kilometer per hour leg. What we do now is we read the problem and try to discern information which can be placed in the chart. So the train travels 395 kilometers over 9 hours. I can't use that immediately. For some of the voyage, the train went 40 kilometers per hour, and for the rest 50. Well, that's 2 cells immediately. That means it went 40 kilometers per hour on leg 1 and 50 kilometers per hour on leg 2. For how long did the train travel at each speed? Well, that's difficult now, isn't it? Because I don't know. I don't have enough to go on, I don't think. So I'll just put A in here and B in there. And by that I mean that the train traveled 40 kilometers per hour for A hours and 50 kilometers per hour for B hours. And that gives us enough to get started, because distance is rate times time. So this cell entry is 40 times A. And this cell entry is 50 times B. Now I have 2 equations and 2 unknowns. The total length of the trip in time is 9 hours, so that tells you that A plus B is 9. And we also have that the total distance of the trip is 395 kilometers. So 40A plus 50B is equal to 395. That's equation 1, that's equation 2. A good recommended way to solve this is to rearrange equation 1 so it reads as 50b is 9 minus a. And this can go in for every occurrence of b in the second equation. That will be simple substitution. We'll finish that on the next page. So now we've got 40a plus 50 times 9 minus a is 395. Multiply through the brackets and we get 40a plus 450 minus 50a is 395. There are like terms here and here. They add to minus 10a plus that 450 still there is 395. Subtract 450 from both sides and you get negative 10a is negative 55. Now divide both sides by negative 10 and you get that a is 5.5 hours at 40 kilometers per hour. But wait, b, remember, is 9 minus a. So b is going to be 9 minus 5.5. So b will be 3.5 hours at 50 kilometers per hour. Let's try another problem. A passenger train and a freight train are currently 300 kilometers apart. They start toward each other. The passenger train travels 15 kilometers per hour faster than does the freight train. The trains pass each other after 4 hours. Tell the speed of each train. Make up our chart. 2 rows, 3 columns. Distance, rate, and time. This will be the passenger train, this will be the freight train. Read the problem, try to find information to insert in the chart. Well, the easiest information to put in is that the trains pass each other after 4 hours. So each train will have been on the rails for 4 hours. There's 4 going in those 2 entries right there, those 2 cells right there. Now I know one thing, that whatever the freight train speed is, and that's unknown, the passenger train speed is going to be 15 kilometers per hour faster. So I add 15 to the freight train speed to get the passenger train speed. Distance, as you know, is rate times time, so this times this will give you this entry, and this times this will give you this entry. So if I multiply 4 times this, I get 4 times x plus 15 going here, and 4x going here. Now this time there's only 1 letter floating around in our chart, not 2, so you only need 1 equation to solve it. And that is the total distance is 300 kilometers. That's the only information I haven't used yet. So that means this plus this is 300. That's how you extricate yourself from the chart. You now say, okay, 4 times x plus 15 plus 4x is 300, and simply solve this equation to find x. So multiply 4 through the brackets gives you 4x plus 60 plus 4x is 300. We see like terms on the left side. 8x plus 60 equals 300. Subtract 60 from both sides, 8x is 240. Divide both sides by 8, and that gives you x is 30 kilometers per hour. And remember, that's the freight train speed. That's x. That's the freight train speed. Proper sentence answer as per your teacher's directions, okay? Now if I add 15 to that, I get x plus 15, which is, of course, the passenger train's speed. If you add 15 to that and you get 45 kilometers per hour, that's going to be the passenger train speed. Nice. Let's try one more problem. It's slightly different, but still can be solved with the 6-cell method in the chart. Very good. Here we go. The crew paddles 7.5 kilometers upstream, that is against the current, for 5 hours. And then they return with the current, of course, in only 3 hours. Tell the speed of the current. So to get this problem underway, yeah, I said before we're going to use the 6-cell method, but I'm going to have to define my variables. In this case, I'm going to let c equal the current speed. Let's see what units are mentioned in the problems. Kilometers and hours are mentioned. So this c will be described in terms of kilometers per hour. And lowercase p will be the normal paddling speed this crew is capable of in still water. So this is going to be still water paddling speed. All right, and that is also going to be in kilometers per hour. You'll see very shortly why we had to take the time to define these variables. Set up the chart next, and we've got this. Distance column, rate column, time column. Those are the 2 rows. A first leg mentioned in this problem is upstream and then downstream. Okay. Let's take information and fill it into the chart. The crew paddles 7.5 kilometers upstream against the current for 5 hours. I'll put 5 in there for time. And then returns in 3 hours. Now the rate is what's complicated, the rate is what's interesting, and the rate is the reason we made these definitions. When you're going upstream, the current is working against you, so your normal still water paddling speed is reduced by the current's speed. And when you're coming downstream, the current helping you out, then your normal paddling speed in still water is helped by the current. To get distance, which is equal to rate times time, I multiply this times this, and that gives me 5p minus 5c when I multiply the 5 through against those. I now multiply the 3 through against those, and I get 3p plus 3c for those 2 cell entries. Okay, so far so good. Now, to get out of the chart and onto an equation, you have to go back to the problem and find some more information you haven't used yet. And that is this, that the distance upstream, which is also the same as the distance downstream, is 7.5 kilometers. So that means this is 7.5 and this is 7.5. So I set up those two equations. They'll look like this. 5p minus 5c is 7.5, and 3p plus 3c is 7.5. That's equation 1 and that's equation 2. Standard model for elimination here, I'd multiply this equation by 3 and this equation by 5, and that gives us matching 15 coefficients all round on the left side. And that would look like this then. 15p minus 15c equals 22.5, the new equation 1. Multiply by 5 through equation 2, that gives you 15p plus 15c equals 7 times 5, 37.5, equation 2. Very good so far. And now, remember, I only want c, I don't need p. So I can eliminate in such a way that p dissolves immediately. So I'm going to subtract downwards. 1 minus 2 will kill off the p but keep the c. And I'll have, if I subtract downwards, negative 30c equals, and if I subtract that, negative 15. If you divide both sides by negative 30, c will be negative 15 over negative 30, which is 1/2 kilometer per hour. Current speed, sentence answer as per your teacher's directions. If you enjoyed this video, please like, subscribe, and share. If you have suggestions for topics for future videos, please leave those in the comments below. Thank you very much.